Let's go through LeetCode 971, flip a binary tree to match a pre-order traversal. For this question, it gives a binary tree root and an integer array voyage. And we can flip some of the nodes from its left to swap its left and right subtrees. So after flip, the pre-order traversal will have the same array to be match the voyage. So it let us to return a list of integers. That is actually the list of nodes which we need to flip because it says that all of the values are unique. So let's look at example one, right? We cannot flip one or two because flip one and two it becomes one, and two becomes its right child, and the pre-order is still one two, right? So it's impossible. So it let's return at least minus one. And example two, right? The pre-order is one, two, three. And if we flip at a node one, right, it become one, three, two. So it matches the voyages. So we'll have a list which have one here, right? So example three, because we don't need to flip. So it will return our empty list. Um, so for this question, actually, what we're thinking about is that we can do like a divide and conquer, right? But this question is 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 a pre-order traversal. So we need to check a current node first. Check if current node equals not. If it equals, for example, we already know those kind of index. Um, if if it equals the index of the voyage or not. If it doesn't, means the whole tree does not able to flip. So in that case, we just return a list of minus one, right? So if current node equals this kind of voyage index, then what we do is that we check its left the index plus one, right? That will be its left. For example, this root is at the index. The index plus one will be its child node's value, right? So trying to see whether the index plus one is left equals the left tree's value or not. If it is, then we just divide conquer to check whether the left child can be flippable and the right tree can be flippable, right? But if the index plus one doesn't equal to its left child, that means we the, that means there is a flip because this value doesn't match. So we don't know where is the right tree start from right now. But the thing is that we are sure that this kind of value is not the tree what we need, right? So we can try to flip to its right based on current value. So what we do is that we add current value to our result first, and then we do we do DFS. It's right. That is we actually physically thinking is that we flip this tree, that is our right child move to its to left child, right? So that what we do is that we divide conquer its right child with the same void integer array. Um, so so um, so doing like this, right? And we add one value to our result. So that means this current node need to be flipped. And also, um, our DFS we should return a Boolean value whether this kind of subtree is flippable, right? So for our DFS, if any divide conquer of its subtree is not flippable, our DFS will return false, right? So in the end, in our result, if DFS return false, just return list of -1, right? So this is the whole logic. The logic here, the one thing is that when we root equals, right, then we check its left and the index +1. If it is left child dot value equals void index 1, then don't need to flip. We just divide conquer its left and the right, right? So let's write code for this. So let's have an integer result equals new array list. What we do is that we are going to have an index passed in as a reference. And in our DFS part, after we check our root, we'll increase this index. So that for every post traversal of a subtree, right, we count those nodes once. So we'll have this one as one, right? So we just return. So our DFS is going to return a value whether this tree is flippable. So root void index result. Right? So if this one is false, is true, right? Then we just return result. Otherwise, we just return arrays as list -1. So our DFS is going to return a Boolean that is means whether this node is flippable or not. And we need to have a void which and an index, right? And list of string results, right? If you don't want to pass in an integer array index, you can have a global variable index, right? But make sure when we count, check a node, we'll have the index plus increase by 1, right? So we'll say if this kind of node equals none, right? Then we just return true, right? Means because it will not terminate. And for this case, we consider non-node is flippable, right? And also for this one, there is no need to there is no nodes actually, right? So we don't need to have the index increase. So here, what we need is that we need to check a current node dot value. If it done equal to yg dot index 0, right? So what we do is that we just return false, right? So after check current nodes, right? We need to um, we need to have this kind of, because we process one nodes, we need to have this kind of index increase by 1. So what we need is index 0 increase by 1, right? So here, what we say is that if node dot left doesn't equal to null, and node dot left dot value doesn't equal to void index 0, right? Means we find this child tree, and um this left child, this is node, it's left child, it's a value, and with this is previous index, right? With current index doesn't match, right? So that means that must have some kind of flip. So in this case, what we need is that we have results to the add node dot value, right? Its parents, um left child's parents is that is the current nodes we need to add, right? Then what do is that our tree flipped, right? So what we do is that we just divide conquer its right tree. We consider that we move the right child to its left already. So node dot right void index results, and the fs node dot left. So let's see. We do this kind of DFS first, right first. After DFS right, those kind of index already moved to that place. As long as there is how many the count of nodes, right? The index will move those kind of counts of steps. So when we finish the write, then our index, this kind of index zero reference is actually moved to the left child position, right? So we'll see void index result, right? And if node dot left else, right? Else that means if add left equals to none, right? None is return true, don't do anything, right? That is just a true case. Or its left child value equals void index 0, right? That means we don't need to flip current nodes. Then we just return EFS node dot left void index result, and EFS node dot right void index result. Right? So this will be the code. So doing like this, you will see every node is actually traverse once, right? So so the things that the good things that is that during our post um uh post order traversal, right? We have the index moved. So this is one of the most the good point, the point for this question, right? And so it is O n time complexity, and space, right? Space will be it will also be O n, right? Because the worst case that every nodes need to flip. And let's also write the Python code for this. So we need a result equals this, right? And let's just have index as a global variable. result if DFS root void we don't we pass the result index as global, right? So there's just say some -1, right? Then we can have diff DFS. So we are going to have a node will be optional because these are now, right? The node and void, which is a list of int, and this one is is returning Boolean, right? So what we do is if uh, not a node, return true. And what we say is that if a node dot value unequal to void index, then return false, right? Then we'll have the index should increase by 1 plus equal to 1, right? Then what we do is that if node dot left is not null and node dot left dot value down equal to void index, right? Then we need to flip. So we have result should append um, node dot value. And we return DFS node dot right. So now it flips. The right part already goes to left right part. And DFS node dot left right. Right. Otherwise, just return. We don't need to add a current node. DFS node dot left right and DFS node dot right. So this will be the code. If node dot value doesn't equal to void, we can set this one as CL dot index.